Try to understand how we can accept a digital input on Raspberry Pi Pico W. We have seen how we can generate an output from Raspberry Pi Pico pins, and we have also seen how you can interface a relay to turn on an AC appliance using transistor switching to Raspberry Pi Pico. Now let's see how you can accept a digital input onto the pin. This digital input may be coming from a sensors or may be coming from a simple thing like a switch or a button. Button or a switch is, I would say, one of the most widely used input device in an embedded system. You need switch button for setting parameters, you need switch button input for making some up or down counter, or any input mechanism which is simple is a button. You have seen a button on inverters, you have seen a button on car dashboards, you see button on your microwave, you see button on your washing machines. They're just everywhere. Now let's see how you can interface with a button into Now let's see how you can interface a button with Raspberry Pi Pico. Now a button essentially is nothing but a digital input, and this is the sample code that we are going to require in order to read a digital input. Now before we do that, let us first try to understand how the digital input can be read. Now this is the Raspberry Pi Pico, okay, and let me go to the commonly used library. Okay, I think I need to refresh my designer once because the internet was gone for a moment in between. इथून edit करशील हा? Okay, so now my ZDA has loaded. What I'll do is I'll simply pick a switch or a button from the library. Okay. Now this is the button. Let's try to connect it to a pin. Let me use the same GPIO26 which we have been using for some time, or this time I'll just make a change to make it easier for me to make the connection. I'll use pin number 1 or GP0. It's just easier, nothing else. And it's a microcontroller, right? So you can connect any pin to any function as you want. Now there are two things that you can do. One is you can connect this button against VCC, or I'll take another button just for the demonstration purpose. You can also connect it against ground. In this case, the VCC should be 3.3 volt. Remember, Raspberry Pi Pico W input lines will not accept anything more than 3.3 volt on its input pin. If you give more than that, the pins will simply get damaged, and you may probably wonder why it's happening, but the pin will definitely be getting damaged. Now, I want you to understand and focus on one problem here, okay? When you connect a switch in this fashion, and when you press this switch, we are sure that the GP0 pin reads VCC or logic 1. But what happens when you remove the button or when you release the switch? In an embedded system, in a microcontroller system, if you are not giving logic 1, it doesn't mean that the pin is getting logic 0. And if you don't ensure that externally, then your pin may go into a floating state or a high impedance state where you cannot understand what is exactly going on this pin, which may lead the system to malfunction. So to avoid this situation, what we do is we connect a resistor over here. It should be a large value resistor, simply to not let high current flow through it, and it's simply for the purpose of giving a particular signal level. What you can do is you can connect a resistor in this configuration to Raspberry Pi Pico. This is something called as a pull down resistor. What happens because of this resistor is when you have connected or when you are connecting the switch against VCC, and if the switch is not pressed, because of this pull down resistor, the potential on this pin of Raspberry Pi Pico W becomes zero or becomes ground. So basically we are ensuring that it's getting logic 0 if the switch is not pressed. And when you press the switch, we basically the pin will get logic 1 through the VCC signal. This configuration is called as pull down resistor. I'm going to put that into this presentation for your easy reference. So this is called as pull down resistor. Now, on the contrary, let's rearrange the situation a little bit. Let us assume that you are not connecting the switch against VCC. You are connecting the switch against ground. Again, the same situation happens. You press the switch, you know pin number 1 gets logic 0. But when you release the switch, you don't ensure that it receives VCC or logic 1. Now, in this case, the same resistor will be repurposed over here. And now, this is called as a pull-up resistor. Job of this resistor is to give the potential on GP0 pin or keep the GP0 potential pulled up to VCC or logic 1. So as long as the switch is not pressed, the pin is reading logic 1, and as soon as the switch is pressed, the pin reads logic 0. Now why am I explaining this to you? The reason for me explaining this to you is because you should know the concepts. Okay, a good thing, rather a fantastic thing is Raspberry Pi Pico does come up with an internal pull up and pull down resistor. Let's see how do we enable them through the programming. Okay, sorry, it's not copied well. I guess even here I was speaking, so let me just copy that properly. Okay. Copy, paste, not working. Okay, let me just take a snapshot and edit over there. So this is the configuration of pull up that I'm going to keep here for your reference. And now let me keep the configuration of pull down for you for your reference. This is a pull down resistor. Okay. So now we have both pull up and pull down documented. Now let's look at this code. So the first line that you have to write when you have to interface any switch is from machine import pin as usual. I'll open my Thorny. I will save this code as LED blink into the computer so that I have access to all of this. I'll just create on desktop a folder. I will be sharing this codes to you for sure. Pico codes. Let me call it LED blink. But make sure when you save something into Raspberry Pi Pico, it should not be titled as LED._blink, but it should be titled as main.py. Now I am taking another new file. I have added this line from machine import pin, usual. Then you can declare your switch in 3 different ways. This is one and these are 2 more. As I told you, with Raspberry Pi Pico, you have a facility that you can use internal pull up as well as pull down resistors. So you don't have to worry about that. Let's assume that I'm going to connect the switch against VCC. So I need internal pull down resistor. And if I'm using internal pull down resistor, I will only use this declaration. SW is equal to pin 13, pin.in, pin.pull up. I will also import time. And then in the while true loop, I'll do nothing. I'll simply try to read the switch. The code is very simple. SW_val is equal to SW.value. It can very well be just a or any variable that you wish to. And then what I'll do is I'll simply print that over here. And then I'll take a delay of 1 second. I just want to know what it prints on this terminal. Remember, this print command is only for your debug terminal. This is not going to print anything on Raspberry Pi Pico because you don't have an output device. So let's try to make some connections over here for this, and let's try to see what it does for us. Now what I'll do is I will save this code onto Raspberry Pi Pico. I will call it main.py. It will replace the existing main.py code that was present over there with this new code. Now what I'll do is I will simply play this and will monitor the input. Can you see? You are reading 1 because you have enabled internal pull up. Now instead of up, if you enable down, save the code, stop the code and play again. Now you see we have enabled the internal pull down register. So all the time we are reading the input as 0. Got that? Now let me stop it, and now let me turn on my camera from my recording software. All right, we have the camera running. Let me just shift it downwards towards my setup over here. Okay, so what I have here is a simple 2-pin switch. It's a tact switch. Okay, now this simple 2-pin tact switch, I'm going to insert that into breadboard like this, and I will have 2 wires from it. One will go to ground and one will go to pin number 1. So as simple as that, we have a pull-up resistor enabled. So I'm connecting this to pin number 1 over here. And now I don't know the ground pin. Okay, again the same confusion. So for that sake, what we have here is our pin out. You can see whichever is the easily approachable, reachable ground. The 3rd pin from the top on the right hand side is ground. This is 1, 2 and 3. That's it. Now let's have the Thorny terminal and this video together over here. And I'm going to press this switch and you will read the status over here. Let me play the code. It's reading logic 1, 1, 1. And now I'm going to press the switch over here. But before I do that, you see in the schematic here, I am using pin number 1 or GP0, but in the code, I have not made it GP0. Instead, it's something called 13. So I need to make it to 0 first, save it, or stop it, and now play it again. As you see, it's reading 1. Now I press the switch and it's reading 0. I release the switch, it again starts reading 1. Press the switch, 0. Release, 1. Press, 0. What you can do along with this is, you can refer to your previous code, whichever code you used to blink an LED or basically generate an output signal, just like that. What I'll do is, I'll simply have an LED output declared over here, but the pin I will use is called LED. That's the internal onboard LED. Now what I can do is, I will print it here and I will also do this. If A equal to 0, this means if the button is pressed. What do you want to do in this case? LED dot value 1, else LED dot value 0. Just an additional experiment. Let's see what it does. Okay. Now I press this switch. Can you see? The LED is powered on. I release the switch. LED is off. Switch on, off. Do you see there is a 1 second delay into this whole affair? Why? Because we have given a 1 second delay. Now I'll just remove this 1 second delay. I will remove the print line also, otherwise it will start printing very fast. And now I will run the program again. Stop and play again. Now just look at how fast it goes. Press, release, press, release, press, release. It's fast. It's quite fast. Sorry for the bad video, but I guess you get the gist of it. So this is how you can interface a single switch or a push button with Raspberry Pi Pico. And this is also how you can interface multiple switches as and when you need. So this is a very simple program. I'm going to give you an assignment on this one so that you can try it out and see how it works out. Thank you for watching this video.